Hello. Hello. So in this lecture, I'm going to discuss about a very important and interesting topic of digital electronics. That is PLA, Programmable Logic Array. So what I observed, most of the students have this confusion how to implement some function by using PLA in a very simple way. So in this lecture, I'm going to discuss about the steps what you need to follow to implement any expression by using PLA in a very simple way. So we can start. Now, what is PLA? PLA is nothing but programmable logic array. Okay. So that you need to implement by using three things. Okay. That you need to remember. One is input buffer. One is known as programmable AND gate. And programmable OR gate. These three things you need to use to implement PLA circuit. So programmable AND gate, what you need to use? If it is written programmable, then you need to use this cross sign to implement that thing. And here also programmable is written for the OR gate. You need to use cross sign to connect those lines. Okay. So what lines you need to connect, that I will show you when I will implement some function. So how these questions are given generally related to PLA. Suppose you can consider this problem. Suppose two functions are given, F1 and F2, that you need to implement by using PLA. So suppose F1 is given as X, Y, Z. This is three variable function. And the main terms are given as 0, 1, 6, 7. And the other function F2 is given as, for example, 0, 1, 6. So we'll take this example and we'll try to see how to implement these things by using PLA. Okay. Now, what is the first step that you need to follow is you need to first what you need to do, step number 1, minimize the function by using KM. Minimize the functions using KMF. So you need to check whether it is possible or not. If it is possible, then you will do the minimization. If it is not possible, what expression you are getting, that only you need to use. So we'll check whether it is possible or not for this current problem. Otherwise, what expression we are getting, that only we need to use without any minimization if it is not possible. So X, Y, Z, 0, 1, 0, 0, 0, 1, 1. So that I am considering that all of you know how to do the minimization by using KML. So let me do the numbering or indexing 0, 1, 2, 3, 4, 5, 6, 7. That is the indexing. Now, what are the values are given in this problem? Here, this is the position 0. Then the next position is 1. Here also it is 1. Then 6. 6th position is this one. Then we have 7. It's this one. Okay. So what we can do, we can combine these two and we can combine these two to write the minimized expression. So if we combine these two, then what we will get? F1 is nothing but from the left side it is X bar, and from the top this is Y bar. Okay, and if you combine these two, what will you get? From the left side this X, and from the top it is Y only. Yeah. From this side, this is 0, 0 means Y bar. Now let's say X bar and this one. 1, 1. This one means this Y only. Okay, correct. Now we'll do the same thing for the second one, same second function. X, Y, Z, 0, 1, 0, 0, 0, 1, 1, 0. So indexing I already given in the last one. No need to do again. Now in this case, the terms are given as 0, 1, 6 for the second function, 0, 1, 6. 0, 1, 6 means 0, 1, and this 6. So in this case, what we'll see, like we can combine these two. So write down these two you have already obtained, that is X bar, Y bar, if I'm not wrong. It's X bar and from this top Y bar. Yeah. And what about this one? This cannot be combined. So for that, what we need to write? It is X, Y, and Z bar. Okay. Now, so this is the first step, what you need to do. In the second step, you need to identify how many buffers are required, how many input buffers are required. So the number of input buffers is equal to the number of variables given in the question. So in this case, 3 variables are there, X, Y, Z. So number of input buffer is 3. Now, the next step, what you need to do, you need to identify the number of AND gate. You know, as I already written in the beginning itself, you need to use some AND gate, some OR gate. So how many AND gate you need to use? Programmable AND gate you need to use. So the number of programmable AND gate is equal to the number of unique midterms. Number of unique minterms. Number of unique minterms. So unique minterms means how many minterms are there which are unique. So you see X bar, Y bar, it is present in this expression in F1 function as well as F2 function. So unique is only one, because this is coming 2 times. So we need to consider this a single expression. Why? Because this is coming 2 times. And if we consider the unique property or unique condition, as I already written here, the number of programmable AND gate is equal to the number of unique minterms. So unique means how many unique minterms are there? Here it is 1, here it is 1, and these things are coming 2 times, means it will be considered as, this will be considered as 1. This is 1, this 1. So it means that 3 unit terms are there. Okay. So if a component is coming multiple times, for that case, you need to consider that you have to consider 1 AND gate to implement that thing. And here 1, here 1. So ultimately you need to take 3. Okay. So that's why unique term is so much important. You need to understand what is the meaning of unique. So what does it mean? If a component is coming multiple times, then for that component you need to implement only, you need to use only one programmable AND gate for that particular component. Okay. So we have used one AND gate for these 2 and this one for 1, for this one 1. So ultimately 3 AND gates are required, programmable AND gates. Okay, that is 3. Now, after that, you need to identify or determine how many OR gates are required. Number of programmable OR gates. Okay. So the number of programmable OR gate is the number of function given in the question. Number of functions. So in this case, 2 functions were given, if you can remember, F1 and F2. So the number of OR gates will be nothing but 2. Okay. So we have almost done. Now we need to implement only the circuit. Okay. Now how to do the implementation? First of all, what you need to do, as in the first step, what you have done the minimization. In the second step, you have identified the number of input buffers, because I already told these 3 things will be required to implement the circuit. So input buffer, how many input buffers are required? We have found out 3 input buffers are required. Why? Because the number of variables are 3. Now we'll do that part. So how to do this thing? So this input buffer is given like this way. And it will have one inverted part. This part. So it means that from X, you are getting 2 output from this input buffer. So this is your input line and you are getting 2 output. So this line will give you exactly X and this bubble line will give you X bar. Okay. And this is the input buffer. Now same thing you need to do for variable Y because you need to use 3 input buffer according to the question. So here also you will get 2 things. One is Y, another one is Y bar. And you need to do the same thing for Z variable also. So these are the 3 input buffers. As we have found out for this question, we have to use 3 input buffers. Now the next thing is number of programmable AND gate is the number of unique midterms that we have found out 3. So number of AND gates you need to use 3 like this way. This is one AND gate. Programmable AND gate will be given like this way. It will be having only one. This way it will be given. Only one input line will be there. And how many we have found out according to the question? 3 AND gates, programmable AND gates are required. Okay. What was the first term we have got? These 3 things we need to implement: this term, and this term. Okay. And this term is coming 2 times. If you do implementation 1 time, so it can be used for the second one also. So X bar, Y bar we need to get first. How to get X bar, Y bar? So this is X bar component, X bar, and this is the Y bar. So you can see here, if you can remember in the beginning itself, if it is written programmable, you need to use cross sign to do the connection. Okay, so I have used cross sign and this one of the connection is done here and another connection is done here. So this is giving X bar, this is giving Y bar because each of the line I have taken from the bubble line. This X bar, this Y bar. And I have not done any connection in the Z line. So what AND gate, this is this out, what is the output of this AND gate? This is nothing but X bar, Y bar. Now what is the next component we need to get? XY. XY is, so this is the X line, this is the Y line, and we don't have to do any connection in the third buffer. So this AND gate is giving X and Y. Okay. Then come to the third component. Third component is X, Y, Z bar. So this is X, this is Y, this is Z bar. Okay, X, Y, Z bar. Okay, this is X, this is Y, and this connection is giving Z bar. So this is X, Y, Z bar. Okay. So all the 3 terms we have got. Now, how many OR gate we need to use here? According to this question, 2 programmable OR gates are required. Now I'll be doing this part, programmable OR gate part. This line will give you 1 OR gate and this line will give you 1. Okay, this for other programmable OR gate. So in this case also OR gate will be having only 1 input. This programmable OR gate will be having only 1 input. Okay, so what we need to do, as in this case, as we are implementing PLA, our OR gate is also programmable. So according to our requirement, we'll do the connection. So first function is X bar, Y bar plus XY. So we'll check which is having X. So this is X bar, Y bar, and this is XY. So this output of the OR gate is giving the function F1. Okay, because here X bar, Y bar, one connection we have done. And here also we have done one connection, and there is no connection in this third line. That's why we are getting only X bar. So what is the output of F1? That is nothing but X bar, Y bar plus XY. That is the output of F1 or this OR gate. Now what about F2? F2 was x bar y bar plus x y z bar. So x bar y bar is given by this line and x y z bar is given by this line. So the output of F2 is whatever given in the question. What expression we have found out, that is x bar y bar plus x y z bar. So this one is x bar y bar, because we have made some connection here, x bar y bar, and here we have made some connection. So that is x y z bar. Okay, so this is the way you can implement some expression by using PLA. Thank you very much.